Hey everyone, so today we're going to be focusing on what a function is and how to determine if something is a function or not. So we have to know what a function is. The definition is a function is a clearly defined rule that converts an input into exactly one output. These rules often come in the form of relations, equations, graphs, tables, mapping diagrams, and verbal descriptions. So today we're going to be focusing on relations, tables, and mapping diagrams. One very important aspect of making something a function is that the x values, also known as the domain, which we're going to define on the next slide, cannot repeat. X values cannot repeat. If x values in any of these forms repeat, it is not a function. And we'll take a look at some examples. Okay, so domain and range. You might have heard of these words before. The domain of a function is the set of all the first elements of an ordered pair. Hopefully you guys remember an ordered pair is x comma y. So it's always that first part, that first value. The domain can also be called x coordinates or inputs. It's also known as the independent variable. Okay, so the range is the opposite. It's the set of all the second elements of ordered pairs. The range can also be called the y-coordinates or outputs. The range is the dependent variable. So domain, x values, range, y values. So in this table, let's identify the domain and the range. And now when I list out the domain and range, I'm going to use what's called set notation. And it's basically just squiggly brackets. It's a way to keep everything in one and to show that it's a set of numbers. So I'm going to just list the domain. So that's my squiggly bracket. And it's just my x values. So 1, 2, 3, 4, 5, and that's it. So I'm going to close it with another squiggly bracket. That's my domain, my list of my x values. It is good to write them in size order, which they are already in conveniently. You don't have to do that, but if you were to see this on like a standardized test, most of the time it is going to be written in size order from smallest to largest. Okay, so I'm going to do the same thing with the range. The range is just the set of y values. So I'm going to do the same thing where I'm going to write my y values in set notation. So I have 1, 4, 9, 16, and 25. And that's my other squiggly bracket. They don't have to be perfect. They can be hard to master after a certain amount of time. But that's pretty much what the domain and range is. Domain is the x values, range is the y. Okay, so a relation is a set of ordered pairs. So this is an example. And we're going to see this example on the next slide also. Here we have 1, 2, 3, 4 ordered pairs. And we can see that we have our squiggly brackets, which makes it a set. So this is a set of ordered pairs. That's what a relation is. Okay, so we are going to be given relations, and we want to identify if they are functions or not. So in this first relation, we have 1, 2, 3, 4, -5, 7, and then 0.5, 10. Now, remember, for something to be a function, the x values, actually I'm going to be even more specific. For it to be a function, x values can't repeat. So that's really important for you to remember when you're doing the examples today. Okay, so we're going to take a look at all of our x values. We have 1, 3, -5, and 0.5. In this example, none of these x values are the same number. None of them repeat. So this is a function. Okay, let's look at the second example. We have -2, 4, 6, -1, -2, 3, and 0.8, 4. Notice how, by the way, in ordered pairs, we can have positive numbers, negative numbers, whole numbers, decimals. So we did throw in some decimals there just to show you that it doesn't always have to be whole numbers. But let's identify if this is a function or not. So we're going to take a look at our x values. Notice how we're not even paying attention to the y values. Y values do not matter in this question. And hopefully you've noticed that these -2 here and here, those repeat. So because our x value is repeating, this is not a function. If the x values repeat, it is not a function. If the x values do not repeat, like in the first example, it is a function. Okay, let's look at another example. So on this slide, we're going to be given two tables, and we have to identify if it's a function or not. Okay, so for table 1, we have our inputs and our outputs. So remember from our domain and range slide, our inputs are the x values and our outputs are the y values. So if you want to write x and y in there to help you out, it might make it a little easier for you to see. So now, like we said, we're not even going to look at the y values. We don't care if they repeat or not. It's not going to help us to identify if this is a function or not. So, excuse me. We will be looking at the x values only. So we have -1, 0, 1, 2, 3. None of these numbers repeat. Remember, -1 and +1 are two different numbers, so these do not repeat. So that makes this a function. Okay, let's look at the next example. So I'm going to do the same thing where we have x and we have y, and I'm going to even cross out the y's. We don't need them for this question. We want to identify if this is a function or not. So let's take a look at our x values. We have 3, 4, 5, 4, and 10. We can see here that the number +4 repeats, so that makes this not a function. Not a function. And that is a T. All right, let's take a look at one more way of looking at relations. So on this slide, we're going to be looking at what's called a mapping diagram. Same question, we want to identify if it's a function or not. So mapping diagrams are just another way of showing the relationship between x and y values. So wherever the arrow is coming from, that's our x value. So this is x, and this is y. So we see -5 goes to -2, -1 goes to -8, 4 goes to 8, and 9 goes to -8. So we can see that these x values are all going to different y values. So that means none of them are repeating. And a way to see this in another way is we can list these values so as ordered pairs so you can have a clearer idea. So I'm going to write these arrows basically as ordered pairs. So -5, -2, I'm going to write that as just like this. You don't always have to do this, but it's a great way to identify if you're having trouble with mapping diagrams, which some people do, not everybody. So I'm just writing these ordered pairs here. Okay, so you can see we had this -1 and this 9 both go to -8, but that just means that the y value is repeating. You can see here that none of the x values are repeating, so then that makes this a function. So when in doubt, write these as ordered pairs to help you. Okay, let's look at another one. I'm going to just erase these so I have a little bit more space so I can do the same thing just so we can clearly see if this is a function or not. X and Y. So here we see -5 to -8, -5 to -2, and then 4 to 8. So this 5 is going to two numbers in the y value. So let's see what that looks like when we write this as an ordered pair. -5, -8, -5, -2, and then 4, 4, 8. So you can see here, when that arrow is going to two different places and it's starting at the same place, that means that our x values are going to repeat. We can see that this x value is going to repeat. So that makes this mapping diagram not a function. So like I said, you don't have to list out the ordered pairs. I always do because it always helps me clearly see where everything is going, and then if the x values are going to repeat. Okay, so we were able to tell if something was a function from a relation, a set of ordered pairs, a table, and a mapping diagram based on the x values. So for it to be a function, the x values cannot repeat.